This lesson is on molarity. What is it and how do we calculate it? There are many ways to describe solution concentration, qualitative ways which are non-numerical, such as unsaturated, saturated, supersaturated. There are also quantitative methods which do include numbers, and the one we're going to focus on today is molarity. All solution concentration is some kind of a ratio of solute to solvent or solute to solution. Molarity in particular is a ratio of moles of solute to liters of solution. Or you can describe it as concentration is expressed as moles per liter of solution. And so again, it's a ratio of moles of solute to liter of solution. And it's important to remember that it's moles of the solute and it's the liters of solution. The liters here includes then both the solute and the solvent. So a correct method to make a 0.50 molar solution of sodium chloride is to take 0.50 moles of sodium chloride and then add enough water to get it all to dissolve and then dilute it up to exactly 1 liter. This line here indicates exactly 1 liter. So when you dilute it up to that point, that liter includes both the solute and the solvent. In other words, it's the liter of solution. What you don't want to do is measure out a liter of water and then add the 0.5 moles of the solute, because that will increase the volume and you will no longer have a liter of solution. You will have a liter of the solvent, but not a liter of the solution. In terms of equations, in using the equation for molarity, we can either solve for molarity, we can solve for moles, or we can solve for liters, or we can solve for grams. If I rearrange this equation to solve for moles, I get the equation moles equals liters times molarity. And to see units, how that actually comes out to moles, here are my liters. Molarity is the ratio of moles per liter. Liters and liters will cancel, which gives you moles. So that is how you get moles. If I want to solve for volume, volume is liters, or we can see it in these second equation there as well. If I rearrange either of these equations to solve for liters, I get liters equals moles over molarity. And so if I want to see the units for this one, here is the moles, here is the molarity, which is moles over liters. Moles and moles will cancel, which would give me 1 over the inverse of liters, which is liters, just as 1 over 1/4 would equal 4. 1 is 4 times bigger than a fourth, giving you 4. And if I want to solve for mass of solute, the mass of solute is going to equal the number of moles times the molar mass. But in molarity, you will not be given moles, you will be given liters and molarity. And so combining those two equations, the number of grams is going to equal the liters times molarity times the molar mass. And if you wish to see units on how that is going to come out, liters times molarity, which again is moles per liter, that causes liters to cancel out, times the molar mass, which is grams per mole, which allows moles to cancel out. So that then gives you grams. Running through a few sample problems dealing with molarity after we cover dilution, of course. In dilution, the amount of the solute does not change. And so if I have a 1 liter volume of a solution that contains 0.50 moles and I dilute this to 2 liters, all I do is add 1.0 liters of water. That 0.50 moles is still there. And remember our equation for molarity, if we rearrange it to solve for moles, moles equals liters times molarity. So the liters times molarity here, which equals this number of moles, must equal the liters times molarity here because it's the same number of moles and the number of moles did not change. Or the general equation for a dilution is The initial molarity times the initial volume equals the final molarity times the final volume. And you are not restricted to use liters here. You can use milliliters, centiliters, whatever volume, as long as you are consistent and have the same unit on both sides, but it does not have to be in liters. Okay, now running through a few sample problems. If I asked you what is the molarity of a particular solution formed by dissolving 2 moles of glucose in 500 mils of water, again, molarity is the number of moles divided by the number of liters. So substituting in, we're told that we have 0.20 moles. We have 500 milliliters. So dividing by 1,000 to convert milliliters to liters gives us 0.5000 liters. And that comes out to a 0.40 molar solution. Again, just moles divided by liters. A more typical molarity problem would look like this. Because there's nothing in the laboratory to measure moles, this number of moles would already have to have been calculated by whoever is performing the procedure. And so a more similar problem or more common problem would be this. If we have 3.36 grams that you can measure on a gram scale in 155 milliliters, what is the molarity of this solution? So the problem gives us grams and milliliters, and again, milliliters can easily be converted to liters by dividing by 1,000. So 155 milliliters equals 0.155 liters. Now we've got to take our grams, convert to moles. That's just using the molar mass from the periodic table. So grams and grams cancel. Now we've got moles over liters. And this problem will come out to 0.517 molar solution. Another variation of the problem, how many liters? So now we want to solve for liters from the equation for molarity. And so algebraically, we can rearrange that to get liters equals moles over molarity. And we're given 10.5 grams of sodium fluoride, and we want to get a 0.200 molar solution. And so again, we need moles over molarity. And so we've got 10.5 grams. We've got to convert that to moles. Again, we do that by dividing by the molar mass of the particular substance that's involved. Grams and grams cancel, gives us moles over molarity, which is really moles over liters. So moles and moles cancels, giving us liters, which in this problem will come out to 1.25 liters or 1,250 milliliters if you were asked for milliliters. Okay, how many grams of sodium fluoride in 568 milliliters of a 1.5 molar solution of sodium fluoride? Again, to get grams, it's simply the number of moles times the molar mass, but this problem does not give you moles, but from the equation for molarity, moles equals liters times molarity. So putting the two together, the mass of the solute in grams equals the volume in liters times the molarity times the molar mass. And so we have 568 milliliters or 0.568 liters. Here is the molarity, so liters and liters will cancel out. Here's the molar mass, so moles will cancel out, and it comes out to 36 grams. In reading this problem, one of the things you should note is the word diluting. So anytime you see the word diluting, you know you need to use the equation for dilution. And you are given an M1, that is a V1, and an M1 and a V2, and you're asked to solve for M2. And so plugging in, here is your M1, your V1, here is your V2, and milliliters will cancel out, giving you molarity, and it comes out to a 0.25 molar solution, which should make sense because if you take 250 milliliters, make it 500 milliliters. You have doubled the volume, so you're going to cut the concentration in half. So instead of a 0.5 molar solution, it will be a 0.25 molar solution. Okay, this one gets a little bit more complicated. What are the concentrations of all the ionic species in a mixture formed by combining 50 mils of a 0.20 molar solution of calcium chloride and a 25 mil volume of a 0.4 molar solution of aluminum chloride? We will use the equation to solve for molarity of moles per liter, but we have to calculate the number of moles using the equation moles equals liters times molarity. So let's start with aluminum. We have 25 mils of a 0.40 molar solution. So again, liters times molarity will give us moles of aluminum. Now we're combining two different volumes. We're combining 50 mils and 25 mils. So that is where the 75.0 milliliters or the 0.075 liters comes from. So liters of the aluminum solution times molarity of the aluminum solution will give us the moles of aluminum, and then we divide it by the combined volume because we're combining the two solutions, and that gives us a 0.13 molar solution of aluminum. For the calcium, we'll do the same thing, and note for the aluminum and for the calcium, there's just one ion per mole, so we don't have to worry about multiplying by a 2 or a 3. So here is the volume of the calcium chloride. There's 50 mils of the calcium chloride times the molarity of the calcium chloride. Again, divide by the combined volume of the two solutions. Turns out that also comes out to a 0.13 molar solution of calcium. When we get to the chloride ion, things get a little bit more complicated because the chloride ion is coming from the calcium chloride and from the aluminum chloride. And for the calcium chloride, there's 2 ions for every 1 mole. And for the aluminum chloride, there's 3 chloride ions for every 1 mole. So now to calculate moles, it's liters times molarity times the number of ions per mole of that particular substance. So from the calcium solution, again, calcium chloride is CaCl2. There's 50 milliliters. It's a 0.20 molar solution, and there's 2 ions per mole. So that is the number of moles of chloride ions coming from the calcium chloride. And for the aluminum chloride, there are 3 ions per mole. So the 25 milliliters times the 0.40 molar times the 3 ions per mole will give you the number of moles of chloride coming from aluminum chloride. And then, of course, we have to add them together to get the total number of moles in the solution of the chloride, and again divide it by the combined volume, 0.075 liters, and that gives us a 0.67 molar chloride ion concentration.